Hi, this is Surabi
Single. Hey, this is actually
Liam,
not a bad picture of you.
Which one?
Except you look
Amy,
Oh, is it my profile?
and Lauren. And today we will be talking about the volume and pressure relationships of gases. It's too early.
So here your phone gets one.
Are you done? I'm so sorry.
It's 7 minutes on.
This is a lot of time. The man who discovered this relationship was named Robert Boyle. He was from Ireland. Basically, Robert Boyle wondered about the relationship between volume and pressure. When pressure increased or decreased, what would happen to volume? Robert Boyle performed an experiment with a J-shaped tube. Basically, he sealed off one end of the tube and kept adding mercury through the other end as to adjust the pressure of the tube. Then, he observed what happened to the volume of the gas and what happened to the pressure as he changed either one. That was a starting level of mercury, and he gradually added more and more. He ended up coming up with this law. It was named Boyle's law, after him, of course. It basically states that volume 1 times pressure 1 equals volume 2 times pressure 2. In this, temperature stays constant. This is an inverse relationship. The two are inversely related. Here's an analogy if you're confused. Imagine you're in a room that's crammed with people. You can barely move. As the number of people in the room increases and increases, you can see that you're more likely to bump into other people as opposed to bumping into the walls of the room. This shows how, as volume increases, pressure decreases. Soon, the room fills up, gets more and more people, and it becomes even more packed in there, leading to more people bumping into each other. If the opposite happened, so if the volume of people decreased, then the pressure would increase. Here's a graph illustrating the relationship between volume and pressure. By this graph, we can see that the two are inversely related, and as one goes up, the other must go down. So a high volume means low pressure, and low volume equals high pressure. How about we do an example? Problem. Okay, so a 2-liter container of nitrogen has a pressure of 3.2 atm. What volume will be necessary to decrease the pressure to 1.0 atm? Now let's take our formula. V1 times P1 equals V2 times P2. We just plug in the numbers from our question into this formula, and we multiply everything out. So 2 times 3.2 on the left side equals, how many? We can see that the final answer is 6.4. So basically, it takes 6.4 liters to decrease the pressure to 1.0 atm. Thank you for watching.
And I said, here's my email.